Welcome to more function tables. Here I have a function table where the rule is y equals 15 divided by x, and I'm given the values of x as 1, 2, and 3. For that first line of my function table, y equals 15 divided by x, 15 divided by 1, 15 divided by 1 is 15. For my next line, I have y equals 15 divided by x, 15 divided by x, or 15 over x, y equals 15 divided by x, y equals 15 divided by 2. 15 divided by 2, 15, that's 7 whole times, with a remainder of 1. That 1, if I could divide it again, I would divide it into 2 parts. 7 and 1/2. Let me write that back in as a mixed number. We would not write remainders in a function table. We would express them as fractions or mixed numbers. Finally, for our last line, for 3, 15 divided by 3 is just 5. So when x is 3, y equals 5. Here's another function table, and you will notice there's a fraction inside of my rule for this function table, which is a perfectly valid thing for a function table. And then so, I look at this first line, it's saying 2, when r is 2. When r is 2, we're talking about 3 of 2, which is 3 times 2, which is 6, plus 1/2, which is 6 and 1/2. And so I'll write that value in there. Can you do that next line, you think? What's the answer? Did you say 15 and 1/2? If you did, give yourself a pat on the back. Look at that last one there. And this is saying m equals 1/2. So if I rewrite my equation, and I have 1/2 equals 1/2 plus 3 times r, I know that 3 times some number plus 1/2 equals 1/2. Oh, I know that this 3r better evaluate to 0. Otherwise, if I add it in, it's going to change this value right here, and it wouldn't be equal anymore. R equals 0. 3 times 0 is 0, plus 1/2 equals 1/2. So, m is 1/2 when r is 0. Here's one more function table where the rule is b equals 9 divided by x. For that first line, we have x being 2. What's b? And in that case, if we solve it, we're going to write b equals 9 divided by 2. b equals 9 divided by 2, which could be written as b equals 9/2. And then so I could write 9/2 in my function table, but to be precise, and what I would like to see, is that you write that as a mixed number. So 9/2 is equal to 4 and 1/2. 4 wholes with that remainder of 1, and if we could divide that remainder of 1, we don't write a remainder in our function table again. See if you can think of that next one for yourself. You can show that work on your paper. And again, write it out as a mixed number and put the mixed number in simplest form if you need to. b equals 9 divided by x, or 9/4, and 9/4, 9 divided by 4, that's 2 whole times with that remainder of 1. So it's 2 and 1/4. And so I have another mixed number inside of my function table. Finally, I'm left with this one right here, b equaling 3. Put it in the right spot. In this case, you would actually be lucky in that if you put it in the other spot, you would have still come up with the right answer. You would have just been lucky, though, rather than good. And it's always better to be good than lucky. Well, I guess it's probably best to be both. 9 divided by some number equals 3. 9 divided by 3. And that's why x is 3 when b is 3. Let me give you one last value. I'm going to extend this, and we call it extending that function table again. And if I extended this function table and said the value of b is, let's say 2, let's see what happens. 2 equals 9 divided by x. To clear the x, I can multiply by x on both sides. That looks a little confusing because I have a multiplication sign. So that's 2x on this side equaling 9. X equals 9 divided by 2. Hey, look, I had that already. I had something that looked like that. It was 4 1/2. Except I had it right here, except it was in the reverse. Let's see if it holds true. If we divide 9 by 4 1/2, yeah, it would equal 2. And you'll have to trust me on that because you probably haven't worked with multiplying and dividing fractions yet. All right, it's time for you to try. Please go ahead and set up and complete this function table. Please hit pause. And remember to put things in simplest form. For that first one, e equals 10 divided by 3. That's 10 thirds. 10 thirds equals 3 1/3. When g is 3, e is equal to 3 1/3. When g is 4, we have e equaling 10 divided by 4, which is 10 fourths, which equals 2 2/4, which can be rewritten as 2 1/2. Remember, I did ask you to write it in simplest form, and also as a mixed number. An improper fraction is never simplified. For our final one, e equals 2. 2 equals 10 divided by g, and so that our answer is 5. And if we think about that again, if 10 divided by 5, does it equal 2? Yes, it does. And so this here is function tables, and function tables with some mixed numbers in there as well. That rule still has to hold for each and every single value.